Welcome to Lesson 15, the one where the abstract finally meets the metal. Walk into any office network closet and you'll see a stack of boxes, tangled cables, and a constellation of blinking green lights. Modem, router, switch, access point. Each does exactly one job. And by the end of this lesson, you'll point at every box and know its role. We'll also decode those port lights because green link blinking traffic is how you diagnose 80% of issues without ever opening a laptop. Let's start with the workhorse of that closet, the switch. Picture a flat box with 8, 24, or 48 ports, each one feeding a single wired device. The magic is that it operates at layer 2, speaking MAC addresses, not IPs, and it learns. First packet from your laptop, the switch notes that MAC lives on port 5, and from then on, traffic for you goes only to port 5. Add gigabit speeds, power over Ethernet for your phones and cameras, and VLANs to slice one physical box into separate virtual networks, and you've got the quiet brain of every office LAN. Now step up one layer. If the switch glues devices together inside a LAN, the router is what glues entire networks to each other. Your home LAN to the ISP to the wider internet. It works at layer 3, reading the destination IP on every packet and consulting its routing table. That rule book that says, for this network, send the packet out this interface toward this next hop. When there's no specific match, it falls back to the default gateway, the famous 0.0 route pointing upward to the internet. And in homes and small offices, it pulls one more trick, NAT, letting 10 devices quietly share a single public IP. That's the reason IPv4 is still hanging on. So let's leave the theory and walk into an actual closet. Top of the rack, the ISP modem, where fiber or coax from outside becomes Ethernet. That's your WAN handoff. One unit down, the router, joining your LAN to the ISP and handling NAT and firewall duties. Below that, the 24-port switch, where every wired device on the floor terminates. And running up to the ceiling, the access points, each one just a switch port away, broadcasting Wi-Fi to phones and laptops. Green light means link. Blinking means traffic. That's the whole stack. Now zoom in on those ceiling units, the access points. An AP is really just a translator, one Ethernet uplink down to the switch, usually powered right over that same cable through PoE, and on the other side, it's broadcasting SSIDs on 2.4, 5, or now 6 gigahertz, with WPA3 handling the encryption. In a small office, you might run 2 or 3 of them standalone, each configured through its own web page, but once you're past a dozen, you hand the keys to a controller, Cisco WLC, Aruba, Unify, and it pushes one config to all of them, manages roaming, watches the load. And remember, concrete walls eat signal, so plan roughly 1 AP per 30 square meters, and when someone reports a dead zone, that's your cue to pull up a heat map. Now walk back to the switch itself and just look at it. Those little LEDs next to each port are talking to you. Solid green means the link is up and happy. Blinking green is real traffic moving. Amber usually means you've negotiated down to a slower speed, and a dark port means nothing's there. That alone solves half your tickets. And on the cable side, Cat5e for almost every desktop, Cat6 when you want headroom or you're feeding a server, and fiber with that little LC connector when you're going switch to switch or across a building. So let's put all of that to work with 4 scenarios you'll actually face. Ticket 1, user says Ethernet is dead. You find their port, LED is off. So reseat the cable, swap the port. Still nothing? It's the NIC in their PC. 2, port LED is amber, meaning it linked but dropped to 100 megabit. Old Cat5 or a damaged cable, swap it for Cat6 and watch it go green. 3, Wi-Fi dies in conference room B. Check that the AP switch port has a green light, that PoE is feeding it, and that the controller sees it. And 4, the scary one, whole office offline. Walk it top down, modem, then router, then switch. Whichever box is dark tells you exactly who to call. Before we wrap, let's lock in the vocabulary. 12 terms. These are the words that show up on every datasheet, every ticket, every closet label. Switch, router, AP, That's your 3-device hierarchy: modem, port, uplink, how things connect to the world. VLAN, PoE, MAC table, the smart behavior inside the switch. And routing table, Cat6, SFP, the brains, the cable, and the fiber module. Memorize these and you're speaking junior network engineer. Now, before you walk into that closet, let me save you some pain. 5 myths that trip up every beginner. Switch and router are not the same. Layer 2 versus Layer 3, even when they share a plastic shell at home. Ethernet cable isn't just Ethernet. An old Cat5 will choke a gigabit link. More access points doesn't mean better Wi-Fi. It usually means interference. A green light tells you the link exists, not that it's healthy or running at full speed. And no, not all switches are unmanaged. Try configuring VLANs on a $20 box and you'll lose an afternoon. Memorize the wrong and the why. And that's lesson 15 in the bank. You've got the switch as your layer 2 LAN glue, the router as your layer 3 network glue, the AP as your wireless edge, and you can read the lights to triage at a glance. Next up, lesson 16, Wi-Fi standards, the whole alphabet soup of 802.11a, BNN, ACA, AX, BE, plus when to use 2.4, 5, or 6 gigahertz. And right after that, the stage 2 capstone. Take a breath, then meet me in lesson 16,